Hi everyone, my name is Diyar and I'm a sophomore mechanical engineering student here at BİLKENT University, and today I will be representing my Phys102 project, which is about understanding the impact of the capacitance to the time constant RC of the circuit. What I mean by time constant is that it's the time passed for the capacitor to charge or discharge to 63.2% of its capacitance. Okay, right now we can focus on the structure of the experiment. Before starting the experiment, I'm discharging my capacitors, and you can discharge it like this. And I also discharge this one. Right now I'll connect my capacitors to my resistance. Each capacitor is 100 microfarad, and my resistance is 100 ohm. So here I'm connecting my resistance to my multimeter. And then I'm going to connect it to my capacitors. Okay, right now I'm connecting it to the resistance. And finally, I'll connect one of my power supplies cable to the resistance. Okay. Now, I'm gonna record the voltage values on my multimeter, and I'm gonna start the power supply. I'll set its voltage to 20. Okay, let's start. After I completed my experiment, as I said before, I recorded the voltage values on the multimeter, and then I plotted the graph of it on the logarithmic scale, and then I calculated the slope of current and time graph, which gives us the time constant of the circuit. When I compare the slopes of both of the setups, I see that the parallel circuit has a completely different behavior than the series one, because we know that if you want to find the capacitance of a parallel circuit, you need to add the capacitance of each capacitor, like C1 plus C2, and it goes till Cn. But if you have a series one, then you calculate it like this: 1 over C equals to 1 over C1 plus 1 over C2, and it goes like this. That's why parallel capacitors have a higher total capacitance than a series one. And here in both of the setups, we see that the resistance values are the same. That's why we correlate time constant directly to the capacitance of the circuit. That's why parallel one has a higher time constant. And the last part, errors. I actually had about 20% of error for the theoretical capacitance versus experimental capacitance for like series and parallel, and also theoretical time constant and experimental time constant error. And I know that 20 is too much. Like, I have never ever done that much error before, and I don't know why. Now I actually know why. For example, I took a video of the voltage values on the multimeter, and then I recorded these values onto the paper by checking from the video, and it's really hard to catch the exact second on the video. That's why there might be some error due to that. Furthermore, we know that, like, since I didn't choose a really huge resistance, like I chose only 220 kilo ohm, that's why the voltage values on the resistor was changing really fast, which is also another reason why I couldn't catch the exact voltage, exact second. What else? Yeah. Also, the crocodile cables that I used were really old, which might create an interruption for the current. Also, there's some heat caused by the resistance, and also the probes of the power supply was kind of loose, which also might be a reason for the interruption of the current. Yeah, some environmental errors, random errors, like plus I'm adding some reasoning. Yeah, these are the reasons basically for the error. This was my Phys102 project, so thank you for listening to me.